Before we start on day 3, I wanted to reiterate a computation that has come up a couple of times so that I can provide you with a shortcut. And here's what that kind of looks like. Let's say you had a given condition problem. So you've got some fraction over some fraction, and let's say you get 3/8 over 5/8. Well, what we saw happen was keep, change, flip. And if I do keep, change to multiplication, flip, these 8s will always cancel. And so your answer, if you look at kind of just a shortcut here, you can just say, if the denominators match, your answer is just the ratio of the numerators. Okay, so I'll probably refer more to this, like instead of saying 3/8 out of 5/8, I might just say 3 out of 5 and kind of cut out the middleman so we don't have to do keep, change, flip a bunch of times in the future. And I'll use that here for number 9, part A. It says 2 fair dice are rolled and the numbers on the uppermost faces are noted. Part A, what is the probability that exactly one die shown is a 4 given the sum of the numbers is 7? So here's our question. What's the probability that the number is a 4, or actually I guess I should say only one 4, and the sum is 7? So if I think of it's got one 4 in it and it's 7 versus all the sums of 7. Well, if we know it's a sum of 7, let's list those first. And I get 1 and 6, 6 and 1, 2 and 5, 5 and 2, 3 and 4, 4 and 3. And you're going to want to look for the one with just one 4 in it. So there are 2 out of a possible, if we do 2 rolls, 6 times 6 is 36, you could say 2 out of 36, over, and then how many add up to 7? Well, that's all of these, 6 out of 36. And we could do keep, change, flip, and then get 2/6 anyway, but this is just a quicker route to that same answer. Reducing, we get 1/3. Here, this one reverses the question to say, what is the sum equals 7 if we already know that there is one 4? Well, the top part we've talked about whether you reverse it or not, it should be the same. So up top here, when we did the same calculation, we got 2. So now we got to ask ourselves, well, how many ways are there to get exactly one 4? Well, you could do a 1 and a 4, a 2 and a 4, a 3 and a 4, a 5 and a 4, or a 6 and a 4, and then you have all the reverses of these. So it looks like there are 10 out of 36. And when we reduce that, we get 2/10 or 1/5. And our last part says the same thing as before, except now they're saying instead of 1 4, it could be at least 1 4. So that just, there's only one other scenario where if we had 2 4s, but this doesn't even add to 7, that would change our denominator. Okay, so 10 plus the extra one that I just had means now the bottom is 11, whereas the top, since it was similar to B, it stays 2, like in B. And there's your answer. Example 10, a group of 6 students consisting of 4 freshmen and 2 sophomores, as noted to the left. 2 students are selected simultaneously and at random. Find the probability that both are freshmen, given that at least one of them is a freshman. Complicated wording there. Let's first just write it as a probability of conditions. The question's asking, find the probability that both are freshmen. Given that at least one is a freshman. So the bottom part's going to be at least, and the top part should be the overlap. So both freshmen and at least. Okay, kind of awkward wording there. But now we can kind of dissect, given what they gave us at the top. When it said simultaneously up here, what this problem is doing is actually mixing together combinations from section 2 with what we have here. So if you think, how can I have simultaneously both freshmen and at least one of them is a freshman? That means I have 4 choose 2. 4 freshmen, and I need 2 of them. They're both freshmen. And then in the bottom part, we would say they are at least. So that would be 2 of them or 1 of them. And if there's 1 of them a freshman, that means that 1 of them is a sophomore. To choose 1. So or means plus, and then there's your 2 scenarios. Either they're both freshmen or one's a freshman, one's a sophomore. Now you might think, well, why aren't we doing the situation of both of them being sophomores? Well, that was the given condition. We're saying at least one is a freshman, so we don't have to worry about the instance where 2 sophomores, both of them are sophomores. We don't have to do that part. So the top part here becomes 6, bottom becomes 14, and I would just put this all into your calculator, which reduces to 3/7 probability. Example 11 says there are 8 girls and 6 boys in AP Econ. The teacher randomly picks 2 students to give a presentation. Given that both are the same sex, so there's your given condition, what is the probability that both are girls? Probability both girls, given that both are the same sex. Okay, so the top part needs to be both girls and same sex, and the bottom needs to just be same sex. The top part, if they are both going to be girls and they're the same, that would be 8 choose 2. You have 8 girls, you're choosing 2 of them. And in the bottom, you could either have 2 girls or 2 boys. And you get a probability of 28 out of 43. 12 is our last example for the day, and then you will go on to finish 3.2 day 3, and then you'll have the weekend. If you want to ask me any questions, feel free. Example 12. It says here there are 7 seniors, 4 juniors, 3 sophomores in farm management. The teacher randomly picks 2 students to go clean up the barn. Find the probability that one is a junior and one is a sophomore. So there's your question. So on the top, let's see, if we did 1 junior and 1 senior, there are 4, I need to pick 1, juniors. There are 3, I need to pick 1, sophomores. Now what was given was that it said they are not in the same class. Class meaning grade. So there's a lot of possibilities here. You could do 1 sophomore, 1 junior, 1 junior, 1 senior, let's put senior, 1 sophomore, 1 senior, and I think that about covers it. Let's just go through our list here. First one, 1 sophomore, 1 junior. Or 1 junior, 1 senior. Or, kind of running out of room here, 1 sophomore, 1 senior. And when we get all this together, what we land on is 4 times 3, which is 12, over, let's see if I can go through this with green, 4 and 3 again, so that's 12. 4 and 7 make 28. 3 and 7 make 21. So if we add together 12, 28, and 21, we get 12 out of 61 for your final answer. If you have any questions, shoot me a message. Outside of that, have a great weekend.